Imagine spending hundreds of hours studying, reading, and rereading notes, practicing the same drills over and over, and still walking away with only fragments of what you tried to learn. Now imagine someone else who studies less but remembers more, picks up skills faster, and seems to make steady, obvious progress. The difference isn't always intelligence. It isn't always motivation. Sometimes it isn't even sheer effort. It can be timing. Your brain doesn't learn at the same capacity every hour. There are biological windows, moments when memory formation accelerates, focus sharpens, neuroplasticity increases, and the brain is literally more receptive to change. Today we're exploring one of the most practical and fascinating frontiers in neuroscience, the chronobiology of learning. How your internal clock shapes memory, attention, skill acquisition, and cognitive performance. Because the future of learning may not be about studying harder, it may be about studying smarter, and more importantly, studying at the right biological moment. Chapter 1. Your brain has a clock. Most people think of the circadian rhythm simply as a sleep timer, a mechanism that tells you when to be awake and when to sleep. But that's only the most visible face of a much broader system. Circadian biology threads through almost every bodily process: hormones, body temperature, metabolism, immune function, attention, memory, reaction time, and overall cognitive performance. At the center of this orchestra sits a tiny structure deep in the brain, the suprachiasmatic nucleus, or SCN. Often called the master clock, the SCN contains about 20,000 neurons that coordinate timing across the body. Through hormonal signals, neurotransmitters, and autonomic pathways, the SCN sends timing cues to organs, peripheral clocks in tissues, and neural circuits involved in learning. Light is its primary cue, but meal timing, exercise, and social routines also shape its rhythm. The result? Almost every cell and every cognitive system receives instructions about when to be most active and when to rest. Chapter 2. Why learning feels different at different times. Have you ever read a page once and remembered it perfectly, then later read the same paragraph 5 times and retained nothing? Most people assume motivation or distraction is to blame. Often the real explanation is biological. Across the day, cognitive performance rises and falls in predictable ways. These fluctuations are driven by interacting rhythms: core body temperature, hormone cycles, accumulation of neurochemicals like adenosine, cortisol timing, sleep pressure, and circadian phase. Some of these rhythms make you quicker to react, some sharpen attention, and others make memory encoding or creative problem-solving easier. So your brain is not a constant, always-ready machine. It's a living system with peaks and valleys of readiness. Learning at the wrong valley can mean the same effort yields much less retention than learning during a peak. Chapter 3. The temperature connection. One surprisingly strong predictor of cognitive performance is core body temperature, something most people don't think about. Over the day, your core temperature follows a rhythm, generally low in the early morning hours, rising through the day, and peaking in the late afternoon or early evening. As body temperature rises, biochemical reactions speed up, neural signaling becomes more efficient, reaction times improve, alertness goes up, working memory stabilizes, and cognitive flexibility increases. Multiple studies find that many forms of mental performance cluster around the daily high point of core temperature. In plain language, a slightly warmer brain often behaves like a faster brain. Enzymes work more efficiently, synapses transmit more reliably, and networks can process information with greater ease. Chapter 4. The adenosine story. Another vital piece of the puzzle is adenosine, a neuromodulator that accumulates while you're awake and signals sleep pressure to your brain. Think of it as the biochemical marker of time spent awake. As adenosine builds, you feel more tired and less able to sustain attention. Caffeine's main trick is temporarily blocking adenosine receptors, masking that sleep pressure and sharpening alertness for a while. But adenosine does more than regulate sleepiness. It affects learning, attention, memory encoding, and cognitive endurance. Too little accumulated sleep pressure and you may feel restless or scattered. Too much and forming new memories becomes difficult. The optimal zone for learning tends to be a middle ground, alert enough to focus, but not so depleted that encoding new information is impaired. Chapter 5. The science of neuroplasticity. Every time you pick up a new skill, learn a fact, or form a habit, the brain changes physically. Synapses strengthen, dendritic spines form and remodel, protein synthesis ramps up, and gene expression patterns shift. This capacity to adapt, neuroplasticity, is the foundation of all learning. Skills, languages, professional expertise, and memories all depend on it. The striking finding from recent research is that plasticity itself appears to vary with circadian timing. In other words, your brain's ability to reorganize and form durable changes is not uniform across the day. Certain windows may be more favorable for creating lasting neural changes, while other times are better for consolidation or lower effort tasks. Chapter 6. Long-term potentiation. One of the core mechanisms underlying lasting learning is long-term potentiation, or LTP. LTP is a biological process where repeated activation of a neural pathway makes those connections stronger and more efficient. The classic neurons that fire together, wire together idea. Practice, retrieval, and repetition drive LTP. Over time, these strengthened pathways underlie lasting memory and skill. Emerging evidence suggests the efficiency of LTP and related synaptic processes is influenced by circadian biology. The same learning episode delivered at different times can lead to different amounts of synaptic strengthening. That means timing can modulate not just how well you pay attention, but how well experiences are converted into persistent memory. Chapter 7. Morning learners versus night learners. Important caveat: circadian timing is personal. Some people are early chronotypes, morning learners who reach peak alertness and cognitive power early in the day. Others are evening chronotypes who are at their best late afternoon or at night. These tendencies are partly genetic and partly shaped by lifestyle and environment. Because of this variability, optimal learning windows differ between individuals. One person's cognitive peak might be at 9 a.m., another's at 7 p.m. That's why copying someone else's schedule often backfires. The goal is not a universal best time, but discovering and protecting your own best times. Awareness of your chronotype can reduce social jet lag, the mismatch between your natural rhythm and your obligations, and improve learning outcomes. Chapter 8. The Learning Performance Triad. If you want to maximize learning, 3 biological systems matter more than almost anything else: sleep, timing, and recovery. Sleep consolidates memories. Without sufficient quality sleep, especially deep and REM sleep, newly encoded information doesn't get stabilized. Timing optimizes encoding. Choosing the right biological moment to learn makes encoding more efficient. Recovery allows adaptation. Recovery includes nutrition, hydration, mental breaks, stress management, and restorative practices. It gives the brain the resources to rewire itself. Many people fixate on total study hours. Elite learners treat biology as part of the training plan. The brain rarely learns well when exhausted. It learns best when prepared, well-rested, and timed to its peaks. Chapter 9. The OXYZEN Learning Protocol. Imagine you want to master a language, code more fluently, learn medicine, play an instrument, or pass a professional exam. Instead of asking, "How many hours should I study?" ask, "When is my brain biologically prepared to learn?" A practical protocol. Track your baseline for 2 weeks. Sleep duration and quality, subjective energy, HRV if available, mood, and which hours feel mentally sharp. Identify your cognitive peaks and troughs. Notice repeatable patterns. Are you most alert mid-morning? Later in the afternoon? Late at night? Protect peak hours for deep learning, complex problem solving, deliberate practice, creative work, and retrieval practice. Use lower energy periods for administrative tasks, organizing, planning, simple review, or chores. Structure study sessions around biological rhythms. Aim for focused blocks, for many people 60-90 minutes, followed by deliberate recovery. Use spaced repetition and active recall to maximize LTP. Optimize ancillary factors. Light exposure in the morning, strategic caffeine timing, avoid late caffeine that disrupts sleep, short naps when appropriate, hydration, protein-rich meals, and consistent sleep schedules. Measure and iterate. Adjust based on performance and how you feel. Work with your biology, not against it. Protecting even a few peak hours each week can produce disproportionately large gains. Chapter 10. The Future of Learning. For centuries, education focused on content delivery, what to learn. The future may place equal emphasis on when to learn. Imagine personalized learning schedules that align assignments and exams with individual circadian profiles, circadian-aware classrooms with adjustable start times, or apps that map your cognitive readiness and recommend specific study windows. A future where timing is treated as a key variable could dramatically improve retention, creativity, and productivity, and make learning more humane and effective for diverse brains. Final thoughts. If there's one lesson to take away, your brain is not a machine. It's a living, dynamic biological system governed by rhythms, cycles, hormones, temperature, and recovery. The people who learn fastest aren't always those who grind the hardest. Often they are the ones who align effort with biology, who study when their brain is ready, rest when it needs rest, and protect recovery so learning can stick. Practical next steps. Track your energy for a couple of weeks. Identify your peaks. Protect those hours and treat sleep and recovery as part of your study plan. Small adjustments to timing can unlock levels of performance you didn't know were possible. I'm Dr. Yende. Thank you for joining me for another episode of OXYZEN Health Intelligence. Remember, the future of learning may already be encoded in your biological clock. Learn to work with that clock, and you may unlock capabilities you never thought possible. And I'll see you in the next episode.